now?
Yeah, maybe you should, I can edit the recording later, but maybe Roberto, you should stop sharing the screen so I show on the video, right?
Okay. So now I stop sharing the screen.
Okay. Hello, everyone. This is Mark Balouz. I'm the president of ISSMGE. And this video is our attempt to start a series of talks. As I promised in my campaign and in my promotional video, I really like to reach every corner of the world and give the chance to every engineer in geotechnical engineering who is practicing geotechnical engineering to be part of these lectures and interact with renowned professionals, professors, maybe contractors even later on. Today, we're starting with this first talk with the TC221 of ISSMGE, the technical committees. By the way, ISSMGE has 31 or so technical committees, and we're starting with TC221. The title or the specialty of this TC is tailings and materials and the challenges of dealing with such material. And we have with us the vice chair of TC221, Professor Roberto Cudmani. He is physically in Germany from the university. He will tell you which it's difficult to pronounce, but I will let each candidate, each participant represent himself. We have also Dr. Asilia Boudiab from Canada, and Ms. Bridget Loco from Ghana, who studied at the University of Kumasi, where we met a long time ago. And I think I remember we danced together during the conference there. Now I will give the floor to Professor Cudmani to introduce himself, and then the other participants. And Roberto, you can start right after they present themselves. Go ahead, please, Roberto.
So thank you very much, Mark, for this very friendly presentation. I am very interested in this experiment that we are doing today, and I hope the people who will see the video will enjoy it. My name is Roberto Cudmani. As you mentioned, I am a professor at the Technical University of Munich, and in the university I am responsible for the area of geotechnical engineering. The name of the chair is very long: soil mechanic, foundation engineering, rock mechanic, and tunneling. Nevertheless, as I mentioned before, one of the focus of our work is regarding to tailings, of course, more from the scientific and research point of view. So I will present some information about tailing to introduce our discussion. So then let me
introduce yourself.
Thank you. I'm glad to participate in the first talk of this series. My name is Asila Boudiab. I'm a geotechnical engineer in training. I work for a consulting company, Wood Environment and Infrastructure Solutions in Canada, and mainly supporting oil sands projects. Back to you.
Bridget.
Hello, everybody. I'm glad to be part of this meeting. My name is Bridget Nana Maloko. I'm an intern in tailings and geotechnical engineering with GODA WSP here in Ghana.
Very nice. Roberto, you can start. I just want to say that even though this is our first one, the topic is very important and we are all ears, especially me, because I know nothing about this topic. I will just be the moderator. Please share your screen.
Okay, I hope you are you seeing the presentation now? Yes?
Very clear, yeah, go ahead.
Okay, as I said before, I have prepared a general introduction to the topic. And of course, today I am representing the new technical committee 221 dealing with tailings and mine waste. First, let me say a couple of few words about our TC. It was established in March 2020. Professor Ramon Verdugo from Chile, Fernando Schneid from Brazil are the chairman, together with me, of this TC. At the moment, we have 91 members from 27 countries. The quite large number of participants and members and countries highlight the importance of the topic. And of course, we encourage other colleagues to become members of the TC and participate of the different activities we are organizing, and of course, activities, ongoing activities. Let us go to the topic, and I would like to introduce the topic saying that, of course, modern societies relies on the products of the extractive industry. Demand for raw materials, for example, iron, lead, nickel, gold, and silver is increasing globally. As new technologies allow the exploitation of lower grade ores, raw material production grows at a greater speed every year. As can be seen in this diagram, the extractive industry is active in all continents with the greatest production in Asia. The figures show the change in the amount of raw materials extracted between 2000 and 2017. As can be seen, the amount of extracted raw materials have increased in all continents with exception of Europe, where the extraction has suffered a small reduction. The increased raw material production has been especially pronounced in Asia and Oceania, but also in Africa and Latin America has been considerable. Therefore, when we speak about the consequence of the extractive industry, and more specific about tailings, we are speaking about a really global issue. The main shortcoming of the extractive industry is that the targeted resources constitutes only a tiny amount of the total volume of ore mined. And therefore, the extraction results in the accumulation of a significant volume of waste material. The waste products of mining processes are called tailings. Tailings are granular materials composed primarily of sand, silty, and clay-sized particles with chemical and processing fluids from mills, washeries, and concentrators used to process the mine's ore. Tailings are pumped with processed fluid, water into so-called tailing storage facilities, TSFs, where they consolidate under gravity until they form a very soft natural soil-like material. These structures belong to the largest man-made earthworks on Earth, with areas of several square kilometers. Whilst mine at the end of the 19th century had a daily production capacity of about 100 tons, some modern mines are processing 50 million tons of ore per day, with the results that the annual worldwide production of this byproduct has increased to the incredible amount of 10 billion tons. In order to have an impression of this quantity, the amount of tailings which are produced in the world every year are enough to cover with a layer of 100 meters thick the city of London, which has a square area of about 100, 600. I know, Mark, you are there. So it's a really amazing quantity of material which is being produced every year and has to be deposited.
Please don't start covering until I leave tomorrow.
So
very nice. Such exciting information. Keep going.
Structurally, a TSF is an impoundment which, depending on the topography, requires one or more so-called tailings dam for closing. For example, the tailing shown in the picture, which is placed in a valley, need only one tailing dam to close. Of course, the tailings are deposited inside the impoundment, and tailings dam must retain the fluids and the tailings as water storage dams retains water. In place, of course, all sides of the impoundment consist of tailing dams, as it is shown in this example from Germany, in which you see from all sides we need these tailings dams. Tailings dams achieve heights up to 250, 300 meters are the largest tailings dam that we have at the moment. These slides show you schematically main construction methods of tailings. Depending on the direction of the construction, we speak about downstream, centerline, and upstream dams. And you see the dam is the part of the tailing which is engineered. Well, that means there is in some way from the tailings, you take the same material and separate some part of the material and use this material to construct the dam. This is not additional material that we are using. And the rest of the tailing placed behind with all the fluids and water as a deposit hydraulically are the tailing materials, which are not non-engineered.
So sorry to interrupt. You know, yes, this is an interactive talk.
Of course.
Which one of these three methods is more common or is mostly used?
It's, of course, the upstream method is the most economical one. That means this is the method which is preferred from the economical point of view. But as you see in this method, the dams are partially placed on the non-engineered tailings, and therefore this is in comparison to the other two methods, is more risky regarding the stability. Therefore, to answer more concretely the questions, there are a lot of tailings constructed in the past with the upstream method, but many countries are banishing this method. For example, Chile has banished this method, and the new tailings cannot construct it with this technology. I don't know if there is some legislation in Canada regarding that. Maybe Asil can tell us something about that. But as I say, different experts say that the upstream method should not be used anymore because of the danger. Others say it is possible under certain circumstances to use this method. It's a matter of discussion of this method will be further used in several countries or not. But until now, there is no general banishing of this method.
I have one more question.
Yes, please.
From the practical point, as a contractor myself, which method is used and how and why? Does it depend geographically on where the mine field is? Like if it's on the right side or the left side? And that's why you opt for A or B or C, or it is an engineering decision?
Of course, there are several aspects which should lead to the decision. But one thing you can recognize here is that if you use the downstream method, you will need to engineer a larger amount of material, and you will need more place because you are occupying a larger place with the dam. And of course, you will need to increase the area of the impoundment. That means depending on the topography, depending on the area available, it can be that you only have the option to use one or the other method. So it cannot be answered in a general way, but of course the situation, the particular situation will play an important role in taking decisions.
One last question, I swear.
Please.
So if you have to choose between A and B and C, you have to look at different aspects. And you said that C is the highest risk. Is it the cheapest because of the number of engineered material? And by engineered, what do you really mean? Is it just compaction or cementation? Or
No,
how far would you go with engineering this material?
There are different methods to engineer this material, but what you do is, of course, you have to extract the fluid from the material, and you will try to separate a very fine material from the complete tailing composition. Because of course you want to construct these dams in with using, let me say, material with the size of sands or maybe larger, in order to have a good drainage and a good stability. But normally there is no any kind of compaction of this material. This is a very big difference to water storage dam, that you are not compacting this material. Sometimes the starter dam, which is the dam which you use to start this construction, can be constructed from let me say with selected material, but the other part of the dam is constructed from materials which are extracted from the tailings.
You're talking about the red trapezoids.
Yes, yes.
That's a lot of work to engineer this material. Extracting the water, filtering,
yes.
sieving the fines. Wow. Sorry, go ahead.
No problem. So maybe it's interesting in order to have an idea of this structure, to compare in some way these structures or these dams with a water storage dam, because there are distinct and challenging features of tailings dams in comparison with water storage dam. The first thing is that tailings are not constructed and designed as a finalized capacity structure like water retaining dam. Instead of that, tailings dams are raised as storage demand increases. Sometimes if, for example, the mining company decide to stop mining because the prices in the market are not favorable, it can be that this structure remains in a certain high several years and will be reused or started later on. Another contrast to water retention dams is the material and the constructions method, as we have described before, that we do not use selected construction material, but we use the waste, selected waste, let me say, to construct the dam. The material composition and geometry of a tailing dam is different, and of course we have, because we are using material which is being extracted, there is an heterogeneity inside the dam because the material with extraction change as well. And sometimes there is a change during the years of extraction. There is also a change in the method of processing the material, and therefore also the tailings are changing. So this is very important. In comparison to water retaining dam, tailings dam are placed hydraulically and are not compacted by conventional compactions machine. This was your question, Mark. In addition, the behavior of tailings are difficult to predict due not only to the complex behavior of tailings materials in comparison to natural soils, but also since the state of the material, for example, the density, the stresses, the structure of the granular skeleton, cementation, are changing during the life of the structure. So the material is deposited in a very loose way. And of course, there's compaction with the time when the weight of the next material layers are coming. So the geotechnical properties and the hydraulical properties are changing during the life of the structure. This makes the analysis of these structures especially difficult. Especially due to the relative large void radius, tailings present a contractive volumetric behavior during shearing. And therefore, during under undrained shearing conditions, they are very susceptible to liquefy and show, of course, like liquefiable materials, a brittle failure. And this is also important when making analysis of the stability and, of course, monitoring the behavior of these structures.
Dr. Roberto, just commenting on Canada state here. So upstream construction is pretty popular here in Canada. I'm not aware of any regulations that forbid such construction, but there are tight control measures from a technical perspective to environmental controls, and then instrumentation, monitoring, reporting to the regulatory bodies up to closure. So it's very well controlled.
Yes, I know that Canada has very tight controls and quality control mechanisms. I have several colleagues working in Canada, and of course it's one of the countries which is taking care of these issues, because they have been in the past, or there were some failures in the past, which of course make aware of all these problems in Canada. Thank you very much for your comment. All this results in a significant higher failure of rate of failure of tailings storage facilities in comparison with conventional water retaining dams. According to the literature, the failure cases of the last century amounts to about 1.2% of all tailings storage facility in the world. This is about 2 orders of magnitude higher than the failure rate of conventional water retaining dams. So, and this is a very important issue. These diagrams in the picture, in the slide, show both the total release volume, released through the failures, and the human life losses caused by catastrophic failure. And as you can see, these both numbers are increasing with the time, despite of the advances in the understanding the mechanical behavior of the material, and of course the improvement in the processing in the processing of tailings materials and construction.
Roberto?
Yes.
This is very important diagram. It's, you know, if you compare it to other geotechnical or civil engineering aspects, I mean, this is crazy. I mean, if I look at the right side, the human life loss, are you talking close to 3,000
yes.
casualties in one event?
No, not one event. These are different events. Yes, you see these arrows.
Oh, you're adding them all the way. Okay.
You are adding from...
But every vertical line,
yeah,
is number of casualty for
yes.
that event.
Yes. And
so the latest one was in Brazil, 2019.
About 300.
And you're talking
people.
About 200, 300?
Yeah, 270 people, yes. Mm-hmm.
Wow, that's a lot.
This is, and
I
this
mean,
is
if you compare it to the latest collapse of the buildings in Miami, I mean, the whole country of the USA is changing the codes, and it was a huge thing, and 90 casualties. I mean, this is
Yeah.
3-4 times more catastrophic.
Yes, so you see the second bullet point is telling you what you are saying. The economical losses of several millions per failure are comparable with those of natural catastrophes. Yeah, strong earthquake, hurricane, and tsunamis and flooding. So you cannot compare it with failure of civil structures, other civil structures. Yes.
Yeah, you're making this talk very, very important, not only to me, but to the whole world. You're opening the eyes of every engineer. I mean, somebody who's working on a dam like this with tailing material wouldn't know that it's that critical and dangerous. I mean, they would just...
that the people working in tailings will be aware of all this. And this is what make it extremely interesting also for education and research, that people, let me say, work in these topics, which is very important for our development. Yes, in the future, to reduce the number of catastrophic failures. Of course, we cannot avoid any failure, but the number of failures should get reduced to a number which is acceptable, which is not the case at the moment.
Yeah, and further to your points also, these high-profile failures, if we can call them, they are really triggering some changes in the mining industry. So the mining industry is trying and actually started releasing some revised, updated and new guidelines to better manage the tailing facilities.
Yes, and one of the reasons why these numbers are increasing in the last years is because, of course, the amount of mining material is increasing all around the world. And also the size of the tailing is also increasing. So the tailing dams are getting higher in order to deposit more material, and therefore these failures are occurring
dangerous
in a larger increasing rate. So there is, as you have said, a lot to do, and it's good that people from praxis get aware of these numbers. But as I say, I think the most people working in tailing, engineers, at least geotechnical engineers, are aware of or they should be aware of these numbers. If you read in the literature, you find that some estimation based on the past, how will be development, and you find that without major changes and substantial reduction of the risk of this structure, we can currently predict about 15 to 19 major failures within the next 10 years. So if the development continues in this way, and this is the reason why we have to do more to avoid these failures. And I think we are doing more if you consider all the effort which is been made all around the world. To go a little bit, but not too deep in detail, but at least a couple of details, is the question is why these tailings fails. And of course, there is plenty of reasons. I choose this plot or this drawing from Santa Marina et al. And here you have some of the principal causes of failures: high water levels due to inadequate drainage, particle size segregation during sedimentation, which produce layers with different hydromechanical properties in vertical and horizontal direction, early cementation resulting from the tailings and from the fluid which is used to process the material with several chemical components, which this cementation allows that the material is formed with a very large void or voids or pore volume, and therefore they have a very open structure and a very sensible structure. And this sensible structure, if you disturb this structure and destroy this cementation, can collapse even instantaneously without any clear action from outside. The other cause of failure is overtopping, when we have heavy rains and the drainage is not functioning in the proper way. Loss of stability of the tailing dam due to static and dynamic loading, especially due to liquefaction of the tailing material. So here the topic of liquefaction is a main issue in the study and the analysis of the behavior of tailings. We can also have failure of the foundation. This has been the reason of some failures which have occurred in the past, that the failure will did not occur in the tailing itself, but in the foundation soil. And we have other causes which are typical for earth dams, like internal piping, erosion, hydraulic failure. And here plays, of course, not only it's not only a question of the design, but also a question of construction, of management of the construction, making implementing all the recommendation of the designs. So some failures occur, of course, because these issues are not properly treated. To finish my presentation, I would like to present one last big failure that we have in tailing facilities, which was the Bromadino failure.
Berto?
Yes.
Before we talk about the Bromadino failure, yes. I had a question on the previous slide, please.
Please.
Because when I look at this dam, I can tell it was constructed the seaway. What would you say is the percentage in terms of usage of dams like this? Is it industrial, or is it for irrigation, or could it be for recreational? Or how do you, in terms of percent, it can be anything?
You are speaking about tailing dams or in general?
Yes, tailing dams.
You cannot use tailing dams for anything, because you have these fluids that you are using to extract the minerals are chemicals which are not good for your health. Yes, so you have contaminants, you have very aggressive minerals,
so it's an industrial dam, only to contain.
Only an industrial dam,
waste.
which has to be closed after the mine is closing, and will be there for the eternity.
Wow. So any failure in this dam is a real catastrophe. It's not just water flowing.
Yes. And
wow.
This is the problem of many dams. For example, Bromadino was already closed. Bromadino, the case we will observe, was closed. I think was closed 2014, and the failure.
Go ahead, show us what is Bromadino, because I heard a lot about it.
Yeah. So that means you cannot use for anything normally these dams. If you want to use the material, of course, there is a lot of intense and studies. We are now participating on a European initiative to see if we can in some way reuse these materials, because there are a lot of resources there. And so we will see what we can do with that, how we can clean in some way these materials in order to allow an utilization of the material for other purposes. But until now, it's not possible to my knowledge.
Bridget just told me that she lost internet.
Yes.
Maybe we can wait 1 minute. I know we're... Maybe if we wait a little bit, and then I can edit the video so that she can be with us.
Of course. We can wait a little bit.
Bridget, we are waiting for you. Try to connect again, please.
Do you like to add something, Asil? Maybe I have forgotten something important in my...
She will have a lot to say.
It's a great background.
Yes, yes, yes.
Yeah,
Of course, this is only a very, Mark, please, this is a rough introduction. Yes, so this is not a talk for expert.
Yeah. No, we don't want it to be a talk for experts. We want it to be for the general public and general geotech, because it is going to be and you don't want to talk about something that another expert has a different opinion. I mean,
we have a lot of things in tailings. It was interesting. We carry out one of the first activities of our TC was to make a questionnaire about 6 key questions regarding tailings, and we will very surprised in observing the answers that we really have very contradictory answers.
Yeah.
This topic, how to deal with the different problems. That means what I am saying is very general, but maybe some of the points I have raised, another expert will say, no, I mean, this is different. I cannot guarantee that everybody will be, will agree with what I am saying, but I think these are general concepts. The most people will agree with this concept I am explaining.
Yeah, it's the same in any profession, so don't worry. Go ahead. Bridget is back with us.
Okay. So, as it was mentioned before, the failures have very often caused a loss of human lives, as well as destruction and contamination of huge landscape with toxic and hazardous tailings. An example from the recent past for a catastrophic event is the breach of the Corrego Failure Dam in Minas Gerais. This is the name of the dam in Portuguese, but this dam is well known as Bromadino Failure, or this failure. And this failure occurred in January 2019. It was really published in all newspapers around the world. It comes in the news, in the television. I think it's very well-known failure. The situation previous to the failure is shown in the figure. As you see, you have a dam, Barragem 1. This is Barragem, is the name, is dam in Portuguese. And this is located on the top of this plot, and during the failure, the first what occurred is the failure of the tailing dam, and after the failure of the containment, of course, the tailing material liquefy, and you have a mud flow that advance through the mine offices along with houses, farms, and roads downstream of the dam. As we mentioned before, 270 people died as a result of the collapse, of whom 259 were officially confirmed dead, and 11 others reported as missing. I think now only 5 people are still reported as missing. The other deaths were confirmed. And to finish this part of the talk, I would like to show a video of the failure, because it's very interesting to see how this mud flow developed after the failure of the dam. This video was taken by a camera of the operator of the dam, which is placed on the front of the dam. That means in this area we are observing the front of the dam, and now let us see if we can start the video. Yes. You see the deformations and...
Oh my gosh. So it's like a global stability rotation.
Yes.
Wow.
And then there is no stop. There are really plenty of videos showing other perspectives of the failure and some vehicles and people trying to come to a safe place and escape of the mud flow, and several persons didn't manage, of course, to come to a safe place. And
I'm looking at the seconds. So this is a very, very fast failure.
This is
no indication or a dilapidation of any form, just a sudden failure.
This is
no warning.
Characteristic of this kind of liquefaction failure, that is a very brittle failure, and therefore there is a lot of discussion about among the experts, if there is possible through monitoring to really forecast this kind of failure. Yes, and there are contradictory data, let me say, and this is one of the things that we have to investigate in more detail in the future, because it will be very important if such a failure will take place, that we can warn the people some hour or 2 hours before the failure in order to give them the opportunity to escape. Yes, but this is, as I said before, one topic of research and discussion among the experts. So
I like here to express my deep sorrow to the people of Brazil, and all my sympathy and condolences, even though it's 2019, but life is so precious.
Yes, it's really interesting. One interesting thing is that the people, so they have some of the canteen of the company was placed very near to the tailing, and the people were, or many people in this canteen died due to the failure. This is really, and I think if this building will have been placed in a higher level, the people will have been saved. And these are the things that we should think about. I think by taking the right decisions and making small changes, we can also save lives. Yeah.
I can see when you said canteen, I looked at the hour. It is lunchtime.
Yeah.
It's 12:30 there. It was 12:30, so it was lunchtime. Wow.
Yeah.
I would like to come in at this point.
Yes.
We can tell greatly that one of the major issues with tailing storage facilities is drainage. So I would like you to discuss, or I would like the team to discuss as part of this lecture or talk on how we have improved on that over the years. Because with this increasing number of failures on one major topic, which is drainage, we would have to find a better way to solve it than using the old ways that we are used to.
Yes, I don't know if we can discuss all in detail, but of course the drainage is an aspect. The designers are aware of that. The problem is to design drains that will keep functioning during a large amount of sheer years of operation of these dams. And this is still an issue, and I know if you look very carefully in these pictures, there will some persons from a very well-known company, drilling company and investigation company, who were performing perforation works at the moment of the failure. So they were trying to improve the drainage of this facility, because they probably, the monitoring showed that the level of water.
Maybe they felt it's dangerous, yeah.
And of course, I think the companies are putting a lot of effort to improve the drainage. Is, as you say, Bridget, is as a principle, a very, very important aspect of the design. But as I say, it's if you have a structure which is working all this time and having this very large deformation as well, imagine you have a drainage pipe, but due to the settlements of several methods that these structures will have, you also have to design a drainage system which will be able to deal with all this deformation of the tailing dam. It's not a very easy task, but I know that the designers and operators are putting a lot of effort to improve all these parts of the design.
Yeah, I would just like to add here on the water problem that that many experts in the field are also advocating now for the dry reclamation methods like filter tailings, but also these come with their own challenges because the tailings are so reactive, and so we solved the problem of physical stability, but now we have the chemical problem. But still more work should be done. But many experts are advocating for the dry methods as well, just to solve this water issue and the problem from the water and further liquefaction of the tailings.
Rien ne se crée, rien ne se perd, tout se transforme. You fix one thing, you end up with another problem. Here, I like to ask Bridget or Asile, whoever wants to start, if you have some slides to show us, tell us more about your experience and know-how.
Yes.
Maybe Asile?
Yes, I will only present this last slide to really summarize what are the challenges from the geotechnical point of view. If we want to reduce the number of catastrophic failures, of course, it is necessary. It's not only a geotechnical issue. Yes, so we have we need really a contribution of all stakeholders, experts, engineering companies, mining industry, manufacturers, contractor, and of course, the public area is also needed here to impose regulations which are necessary to regulate all these works. And these regulations should also contain not only the design and the operation, but also the closure of this tailing storage facility and the controls that are necessary after the closure, because as we have seen, these structures will be there for the perpetuity. In this ongoing process, the contribution of geotechnical engineering is manifold. We are doing a lot of effort to improve the understanding of the behavior of tailing materials, which has some similarity, but also important difference to natural soils, to develop new methods to describe the hydromechanical behavior, develop more appropriate sampling and laboratory testing methods, and especially field testing method, because sampling undisturbed tailings, it's a very difficult task because we have sandy, silty soils, which are in general very difficult to be sampled in an undisturbed way. The limit equilibrium analysis, which assumes a rigid plastic behavior of soil, shall be replaced by advanced numerical method in combination with advanced consultative models to more realistically describe the behavior of tailings. Geotechnical monitoring and more advanced geodetic and satellite monitoring methods has to be developed and implemented to control the behavior of the tailings, and eventually to help numerical models to predict the onset of failure and early warn people before the failure occur. And of course, all this knowledge will have to be made available to the public in standards and recommendations. So a very big amount of task, and one of the vision of our TC is to create international courses on geotechnical engineering with a strong focus on tailing materials, which are missing at the moment at the university. So very few universities are giving special courses and master degrees in tailings. And in our opinion, we need this kind of education because of the speciality of this material and the speciality of the problem we are facing with. Thank you very much.
Thank you, Roberto, and stay on alert because you're going to have something to say when Asila and Bridget present something.
So I will
go ahead.
Stop my
share your screen. Yes.
Yes, Bridget, or who would like to continue? Bridget or
alphabetical order.
Then
I'm ready. Yeah.
You're ready. I will project your
AA.
And let me put it.
You're gonna share your screen, Asile?
Yes, yes. I will share because we have some problems with the presentation.
Okay. Yeah.
So, are you seeing the presentation now?
Yeah.
In the right mode?
No, it's not in the presentation mode.
Okay. So now it should be right?
No.
Not yet.
Not yet. Whoa.
Maybe swap screens if you have a couple.
I changed the screen. So now it's correct.
No, not yet.
Wait. Then I will stop again and make it a game. I don't know how it's.
Don't worry, I will edit the video, so don't worry.
No problem. It must be a problem with the presentation yet.
No, I don't believe it. It should. It's strange because. So, which
is it yours? So it should work.
This is not the right one.
Yeah. Can you please scroll up to the first slide just to give credit to my reviewer? Okay. Yeah. Okay. Sounds great. So thank you, Dr. Roberto, for the background and for explaining the concepts. For my part, I'll be focusing on the management of tailings resulting from the oil sands mining in Northern Alberta and the reclamation challenges, kind of my area of practice. Next, please. As per the Oil Sands Facts and Statistics portal by the government of Alberta, Alberta's oil sands has the 4th largest oil reserve in the world after Venezuela. As you can see here, Alberta oil sands are found in 3 deposits: Athabasca, Cold Lake, and Peace River. The oil sands that are relatively shallow to be recovered from surface through open pit mining constitute only a limited portion of the Athabasca deposit and are mainly localized near the Fort McMurray area, as we can see here. This is a zoomed in view into the Fort McMurray area. North is the town where people who support operations mostly reside, and then we can see many of the tailing ponds, and further expanding further north where we have active mining, and there are also many mines that are planned to be opened in the future. The rest of the oil sands in the other areas are buried deeper underground and are accessible through other in situ means. Although only 20% of oil sands, of Alberta oil sands reserves are recoverable by surface mining, still the management of tailing resulting from these operations still constitutes a major challenge. Next slide, please.
Yes.
So based on a report submitted by the AER in 2021, which is the Alberta Energy Regulator, the total volume of fluid tailings, which include both legacy old tailings and new fluid tailings in the Athabasca oil sands region, increased from 1,075 million cubic meters, as we can see on the left of this graph, in 2014 to 1,360 million cubic meters in 2020 as operators ramped up the bitumen production. So Dr. Roberto in his presentation explained what are the tailings and why they can be problematic. So it's already covered. I just want to say here that these tailings are stored in tailing ponds for an extended period before they can be appropriately managed. There is water that separates from the tailings on top of the pond. It is mainly recycled and used to support operation. There is zero tolerance of releasing the water from tailings into the environment, so it must stay within the limits of the operations area. However, the fluid tailings underlying the water can take several decades to settle and achieve satisfactory properties for closure if we don't intervene to improve the dewatering or densification. These tailing storage facilities, just by their nature, they pose a risk to the lives of the local residents and to the environment. As Dr. Roberto mentioned in his presentation, in the last decade has witnessed many failures of high-profile tailings dams, and these failures were not triggered by any extreme factors. So following these really scary incidents, the leading entities in the Canadian mining community, they published revised and new comprehensive guidelines to improve dam safety. And now the regulators are compelling the companies to find timely, safe rehabilitation solutions for their deposits. Talking specifically about Alberta, all these reclamation activities are managed through AER, which is the Alberta Energy Regulator. In 2017, AER released an updated Directive 085, which is entitled Fluid Tailings Management for Oil Sands Mining Projects. And this directive is guided by the TMF, the Tailings Management Framework, which was announced in 2015. This directive tackles both existing legacy fluid tailings and new fluid tailings growth. It requires companies to submit tailing management plans with a goal to minimize fluid tailings volumes and progressively reclaim only within 10 years of the mine's end life. So in order to meet this strict deadline or time frame, mechanical and chemical remediation technologies are currently being practiced in order to improve the dewatering and densification of these tailings and speed up the reclamation to meet the 10 years time frame. As of now, the water capping of fluid tailings is not yet authorized by AEI, and it's subject to further evaluation. Other reclamation methods, like dry reclamation methods, which involve unsaturated tailing, are mainly focused on the geotechnical characteristics of the tailings and focused on achieving the physical stability of the reclaimed structure. But as I just said, the physical stability of the reactive tailings is always competing with the chemical stability, which create a conflict in the design. One example of these dry methods is the filtered tailings technology. A recent study by Dr. Wilson in 2021 suggests that to be able to implement these dry technologies successfully, we have to have a good handle on the control of the degree of saturation And we have to embrace the application of unsaturated soil theory, which is not the standard in our industry yet. So along the same lines, more work should be done here, and other solutions like a mixture of tailings and waste rock designed with the appropriate proportions and geotechnical properties are proposed as one of the alternative solutions.
Sorry to interrupt, Asile,
yeah.
but those fluids that understood from you and Roberto are poisonous, right?
Yeah.
Is there in a different profession like chemical engineers working on reusing this material? Or because if we keep doing that, as I look at the curve, it's crazy. We're killing the earth worse than, cutting the jungles of Amazon. We're doing worse here because we're not killing the tree, but storing something poisonous that can kill us all. Any knowledge about such research?
Yeah, like there is ongoing research on all this tailing material. The main challenge is to dewater these tailings. So taking them from a fluid state to a more solid state, then you can cover them and reclaim them for sure with proper containment so that we don't affect the environment. But dewatering and densification is still a major problem, and it's still research. There are a couple of successful reclamation activities or projects that I will touch base on now. But yeah, research is ongoing on densifying, dewatering these tailings faster, or put them to other uses. So just further to this point, I would like to shed light on a couple of projects that were successful reclamation projects. Next slide, please. So this is one example. In 2010, Suncor became the first oil sands company to reclaim a tailings pond to a trafficable wood forest and wetland environment, as we can see here. The procedure mainly consisted of moving MFT, mature fine tailing, from this pond to other ponds, then backfilling it with reclaimed tailing sand, and after that, constructing and planting the surface. We can see to the right the final reclaimed area. Next slide, please. So pond 5 is the next oil sands tailings pond to be reclaimed by Suncor. Back in 2009, the reclamation.
You're giving positive, positive stories, because before it all depressing. Now we can smile a little bit. Thank you. Yeah. Keep going. Sorry to interrupt.
I would say, yeah, there is hard work that is put just to improve the practice. And yeah, these couple of projects are just some case studies, and hopefully in the future we'll see more and more ponds that are successfully reclaimed. So back in 2009, the reclamation activity started for this pond 5. As we can see back then, yeah, this is to the left, the 2009. It was all tailings. Back then, the thickness of the tailings varied from less than 1 meter to 50 meters deep, so which is a lot. And then the solution that was proposed was a coke cover. A coke is also another byproduct of the oil sand production. It is lightweight and the cohesionless. It looks like a coal. Yeah, it is cohesionless, lightweight. Before placing the coke on top of the fluid tailings, there was one layer of geotextile and one layer of geogrid that were anchored to the surrounding dikes and the beaches. The placement of the coke then started by a network of roads, as we can see in 2010. So here they started the network of roads. In 2011, the roads were already completed, and they came back and they started filling the cells between the road. 2012, the cover was already there. And then this cover was used as a platform to install VSDs, vertical strip drains, to help the tailings underneath the cover in the dewatering and densification like faster. As of 2017, there was like 2-meter cock cover. It was raised up to 4 meters in 2021. This surface is perfectly trafficable, and huge equipment can drive on top, like haul trucks and other really big equipment. And more cock lifts are planned for the near future and like the coming few years. And whenever the cock reaches the design elevation, it will be covered with a soil top and planted. It will be reclaimed to its natural state. The ultimate goal is to return all these areas to the government for public use. And with this, I come to the end of the presentation. I'd just like to scroll down to the next slide to present the references, please. And I would like to add here that the government of Alberta is periodically reviewing and updating its policies to reflect its commitment to decreasing risks from tailings, to manage the environmental effects, and to foster innovation to increase the speed of reclamation of these tailings facilities.
Excellent, excellent work, Asile. I think you're an expert. You should think about joining the TC. So you have to talk to Roberto on the side.
I would like to, but scary big names there. Maybe I need a bit more experience.
Everybody can participate. There is no limitation.
No limit, yeah. Bridget, are you ready? Bridget? We took a long time. I thought in half an hour we'll be done, but it's so exciting and interesting. I'm not going to stop you. I think we lost Bridget.
Yes.
Being Ghana maybe is challenging to have a good Wi-Fi. We'll wait for her another minute because she's been waiting for a long time for this moment. The idea is to encourage people from all over the world to participate. So, Bridget, it's your turn. Don't leave us. Unmute, and it's all yours. Okay, love your smile.
Thank you. Let me share my screen right now.
Share your screen.
Okay.
Challenges.
Okay, so I'll start my talk on the challenges in the world of tailings and geotechnical engineering in Africa. We've already gone through the term, what tailings is about. So I will touch on why it is critical. Tailings is a critical topic because of the chemical component of the tailings and then its effects on the environment and on human beings. Now we take geotechnical engineering on its own as a subdivision of civil engineering, where we improve on the earth material. We study and we improve on earth material for defending our society and life. All infrastructure, everything you can think about, depends mostly on geotechnical engineering. Now, I'll talk about the challenges we have in our field as geotechnical engineers. As geotechnical engineers, tailings engineers, one major challenge is understanding the drainage properties of tailings and understanding the drainage properties of tailings and then designing adequate drainage systems for TSF to accommodate the tailings. Now, we all know that one major issue with TSFs are drainage systems. One, we don't understand feelings and their reactions with other systems. We are looking at different parts of it. We are looking at the parts that is used for stability components. And we bring up that as heavier, bigger particles, ranging from bigger particles to intermediate particles, then to finer materials. Now, over the years, from Dr. Kudmani's lecture or talk we just had recently, over the years, we've seen so much failure. We are struggling in Ghana or in Africa, understanding drainage and keeping it stable or protecting our TSS or our environment. Would also like to look at and expertise in the tailings industry and incorporating all expertise and knowledge from different aspects of engineering in designing and operations of tailings. Now, in designing and operations of our TSF dams, we don't have just the geotechnical aspect. We have the hydraulics, we have the mechanical engineering, we have the geological, hydrological, pumps and pipelines and chemical aspects of our TSFs or of our tailings. We're putting all of this interdisciplinary aspects of engineering together to bring up a good or a concrete design system of our tailings to be able to manage and control its effect on our environment has become one major pressing topic in Africa here, or in the mining industry in Africa. Our next issue or challenge in Africa here is our type of materials or the type of soil found in Africa. In our tropical regions, we have mostly laterite, different from most of the soils we find in the other parts of the world. Now we look at these types of soils and then the codes and guidelines that have been done over the years through our technical or our professional team. If we look at the BS codes, the ASTM codes, and the other codes, we would find out that some of the parameters that are used in these codes do not adequately fit in the parameters of our lateritic or saprolitic soils. So we usually have to do interpolations or some assumptions to be able to come out with a complete or concrete design that makes sense. Usually with that kind of design, we have loopholes where the engineers or the designers do not actually, we are designing, but we are not designing with the actual values or actual parameters. We are doing assumptions and interpolations. So getting a design that you are confident in, or getting a design that you can stand, or have codes that can defend these designs are usually a lacking thing that we have. It would be good as Africa or as technical people who understand what saprolites and lateritic soils have to be able to provide a standardized system for geotechnical engineers or geotechnics in Africa here. Now, the last thing, or but that's the last thing I would like to talk about is the computational methods used in modeling of soils. We have two different interests of discussion, which is the discrete element method and the finite element method for soil modeling. Now, it is noted that usually most softwares use the finite element method. However, the discrete element method may be better suited for soil modeling because of the concept behind the discrete element method. It would be interesting to discuss the peculiar challenges the geotechnical engineering industry faces with implementing the discrete element method technique into our existing softwares that we have currently in our field of geotechnical engineers. I think, thank you.
Bridget, do you know of any project that failed or is a success story in Ghana or neighboring countries? Like, I know you're working on investigating tail sites, but have you been or involved with a case where it's either a success story or a failure?
Okay, so we had the last one, the project I was on was in Burkina Faso, where we had the TSF raise for the Tapako mine. It was a success story. It was a success story, not a story of failure. So they had an existing dam where we had to do a raise to tailings. So we employed the method of, into the tailings dam and a part outside the tailings dam. And during sites or during the construction works, we also had to do some checking the monitoring boreholes that we had around to make sure they were functioning well. We had to look at the pipes. We had to make sure that the material they had on site, which is the rock ores, the waste ores. And we're using the waste ores as the stability components with some saprolites as the intermediate components. And then the final materials or the tailings as the fine parts of the TSF dam. That was in the year 2020. Yeah.
Mm-hmm. Interesting. Thank you. Roberto, do you want to add anything or comment on what the engineers?
It is interesting. I can remember because I made my master degree in geotechnical engineering in Brazil, and they have the same complaint like Bridget, that because they are also dealing a lot with tropical soils, saprolitic soils, residual soils in general, and they made the same complaint that of course they cannot apply this all the methods which were developed for let me say soils in temperate regions. And myself, I made my master thesis on studying the behavior of shallow foundations on residual soil. So I carry out loading tests on this soil. So it was interesting to hear you. My recommendation will be that you try to get in contact with Brazilian people, because they have a rather good developed geotechnical engineering, and they have dealing with this kind of problem. I think this for sure a possibility to cooperate between Africa and Brazil regarding the behavior of soils. Yeah.
You're on the same latitude line.
Yes, it's are very similar problems that they are facing.
Yeah.
Yeah.
And any comment on? Sorry, Asil. Any comment on finite element or discrete element?
Yes, of course. This should be or could be another matter of a lot of discussion, but only to one comment, because you mentioned two methods. One is the discrete element method, the other is the finite element method. And there is a main difference between these two methods. One is considering the soil as a continuum. This is the finite element methods, and therefore applying all the theories for continuum materials. While the discrete element methods, it's modeling the individual particles. And therefore, the amount of soil that you can model with the discrete element method, it's very small. Yeah, let us assume until now you can model maybe 10 millions of particles. And this is if you have fine sand, are the particles which can be put in a glass, in a cup. So it's a very amount. So, and therefore the method is very interesting to understand, and we are using it to understand the behavior of soils, because you can really model the soil in details, and you can model a laboratory test, for example. For that is a very powerful method, and for sure to understand liquefaction of soils and the influence of cementation, grain crushing. So there are a lot of things that we have to better understand in geotechnical engineering. For that is the method very interesting, but we are not still in the position, because of the computing capacity, to use the discrete element methods in practical problems. There is an exception when you are considering rock, because the behavior of rock is controlled by discontinuities. And of course, if you are modeling rock, you have very large blocks. You can model each block as a particle, and you can model the discontinuities. And this is a method which is being used in rock mechanics. So in rock mechanics, you can use the method because if you have very big blocks. But in soil mechanics is still difficult, but for research processes and to educate people, because you can see inside the granulate. Yeah, you can understand a lot if you see the grains and you see the distribution of forces, and you understand that the soils is not a continuum, but is made of particles. And this is very interesting, and I like the method very, very much.
Thank you, Roberto, for clarifying the difference and where to use what. Thank you so much. Asile, you had something to say before I conclude?
Yeah, I just had a general comment when they were mentioning about the residual soils, just about the beauty of geotechnical engineering. So there's no one method that you can apply everywhere, right? So every project is different. You have to go on a case-by-case basis. It is challenging, but that is where the beauty is. So you need a technical background, but also lots of imagination. That was my general comment. And for the modeling part, Dr. Roberto covered it very well.
And I, as I say, I told always my students, yeah, if you want to do always the same thing, and you have to have a receipt to do something, do not get involved in geotechnical engineering. So this is, as you say, the beauty of geotechnical engineering, that every soil is different, every place is different, and you have to find different solutions as engineer for the different problems you are faced with.
Thank you, guys. I think it's time for me to conclude this talk. I hope we succeed in launching the series of lectures or talks. We will find a name for this series. But for now, I really like to thank you so much. It was very educational, very important to see the general aspects with Professor Kudmani, to see what is being done in Canada with Dr. Asile, and with Ms. Bridget explaining the challenges in Africa. It was the purpose of me preparing this to show that the world can come together in the geotechnical family, have people from different sides of the world talk about their know-how and their experiences. Thank you so much. Hopefully, many will watch this and learn about tailings and the challenges of tailing and tailing materials. I want to thank you again, and for the next topic, I still don't know what it is, but you have to watch it also, and we will release this video very soon. Thank you.
Thank you very much, Mark. Bye-bye. I will send you the video, right?
Yes. Send it to me, maybe Dropbox or
yes.
Maybe you upload and we can play with it there. That's up to you.
Very well. Have a nice weekend.
Thank you. Bye-bye. Have a great day.
Bye-bye. Bye, Roberto.